Whether you are a developer, a student, or just someone curious about how the internet actually works, this channel is built for you. Welcome to Backend Explained, where we take the most important backend concepts and break them down with real stories, real examples, and zero confusion. Every week, one concept. Explained clearly. Explained completely. In 2012, Twitter was in trouble. Users were growing by the millions. Every second, thousands of tweets were flying across the platform. But the app was getting slower. Pages took minutes to load. Engineers were panicking. What went wrong? They had picked the wrong database. That one decision cost them months of engineering work, millions of dollars, and nearly brought the entire platform down. Now you might think that is Twitter's problem, not mine. But here is the truth. If you do not understand what I am about to explain today, you could write the most beautiful code in the world and your app will still break the moment it starts to scale. Today, we are going to settle this once and for all. SQL versus NoSQL. Which one, when, and why do the biggest companies in the world use both? Let's picture this. You are building an app, users are signing up, data is flowing in, and someone on your team asks, which database are we using? Most developers do the same thing. They Google it, they pick the first result, they copy-paste it into the project, and they move on. But that one decision shapes the entire future of your application. Speed, scalability, data integrity, all of it depends on this single choice. Look at Shopify, still running on MySQL, a SQL database, handling billions of dollars in transactions every day. No problems. Look at Netflix, running on Cassandra, a NoSQL database, streaming to 200 million users simultaneously across the globe. Same goal, different solutions. Why? To understand that answer, we need to go back to the beginning, back to how data is actually stored. 1970. An IBM researcher named Edgar Cord sat down with a very simple question. What if we could store data in an organized way with the relationships between different pieces of information? He imagined the answer as a table, rows and columns, like a spreadsheet. Every row is one record, every column is one property, and every record follows the exact same structure. Take a users table, ID, name, email, city. Every single user has these four things. No exceptions. Clean, consistent, predictable. But here is where it gets powerful. These tables can connect to each other. A user places an order. That order links back to the user. That order also links to a product. And that product links to a category. This web of connections is what makes it a relational database. And SQL, structured query language, is the language you use to talk to it. But here is where it gets powerful. These tables can connect to each other. A user places an order. That order links back to the user. That order also links to a product. And that product links to a category. This web of connections is what makes it a relational database. And SQL, structured query language, is the language you use to talk to it. But SQL has one more superpower that nothing else can match. It is called ACID, A, atomicity. A transaction either fully succeeds or fully fails. There is no in between. C, consistency. The data is always in a valid state. I, isolation. Transactions do not interfere with each other. D, durability. Once something is saved, it is saved forever. Even if the power goes out, your bank account runs on SQL. Because when you transfer 10,000 rupees and the system crashes halfway through, a ACID guarantees that money does not disappear into thin air. SQL is the right choice when your data has clear relationships, when accuracy is non-negotiable, and when you need the power of complex queries. Banking, e-commerce, booking systems, HR software, these are SQL's home ground. Fast forward to 2004. Google had a problem that had never existed before. They were indexing billions of web pages, petabytes of data growing every single day. And this data simply did not fit into SQL tables. Why? Because web page data is irregular. One page might have 5 attributes, another might have 500. A fixed schema was impossible. So Google took a completely different approach. Instead of a table, they used a document, a flexible JSON-like object that could hold whatever shape the data needed. Look at a MongoDB document. One user has name and email, another user has name, email, a skills array, and a nested address object. Same collection, completely different structure. And NoSQL handles it without blinking. But NoSQL's real superpower is horizontal scaling. In SQL, when your data grows, you make your one server bigger, more expensive hardware, more powerful machine. But there is a ceiling. In NoSQL, when your data grows, you simply add more servers. Spread the data across them. There is theoretically no ceiling. Instagram stores over 100 million photos every single day. No single server can hold that. So they spread it across thousands of servers around the world. That is what NoSQL makes possible. NoSQL is the right choice when you need massive scale, when your data structure varies between records, when speed is the top priority, and when you are building real-time applications, social feeds, notifications, live dashboards, IoT sensor data. By now you are probably asking, okay, I understand the difference, but how do I actually decide? Here is the simplest way to think about it. Does your data have clear relationships between entities? Users connected to orders, orders connected to products? Choose SQL. Does your data vary wildly between records? No fixed structure? Choose NoSQL. Are your transactions mission critical? Payments, bookings, anything financial? Choose SQL. You need ACID. Do you need to handle millions of writes per second? Real-time updates from thousands of users simultaneously? Choose NoSQL. And the best part? Let the biggest companies in the world show you. Instagram uses PostgreSQL for users, posts, and follows. But they use Cassandra for the activity feed, billions of writes per day. Netflix uses Cassandra to store every user's watch history and serve it instantly to 200 million people. Shopify runs entirely on MySQL. Billions of dollars in transactions. SQL handles it perfectly. Uber uses PostgreSQL for core business data, and their own NoSQL system for real-time location updates from millions of drivers. Notice the pattern. None of these companies are arguing about which is better. They are using both, each one doing exactly what it does best. Here is the most important thing I want you to take away from this video. SQL versus NoSQL is not a battle, it is a collaboration. When you are building an application, ask yourself two questions. First, does this data have strict relationships and require perfect accuracy? Then use SQL. Second, does this data get written at massive speed, vary in structure, or need to scale across millions of users? Then use NoSQL. Most serious production applications at scale use both. SQL for the core structured data, NoSQL for the high velocity, high volume data. This is not beginner thinking. This is exactly how the engineers at Instagram, Netflix, and Uber think every day. Now it is your turn. What database are you using in your current project? Or what database have you always been curious about? Drop it in the comments below. I am going to read every single one and I will reply personally. Next week, we are going inside APIs. Every app you use every single day runs on APIs, but most developers cannot explain exactly how they work. Next week, we fix that. If this video was useful, one like goes a long way in helping this channel grow. And subscribe so you do not miss next week. See you next week. Backend Explained.